I will share with you why it is important to conduct Measurement System Analysis (MSA), which consists of GR&R and calibration in this video. This is a very popular topic in quality engineering job interview. This video will build your foundation to understand MSA as a measurement process, the purpose of conducting MSA, and it will help you to answer MSA interview questions with confidence. Without MSA and GR&R, all data collected through inspection or measurement of manufacturing parts will be meaningless. You will not be able to do quality improvement with meaningless data. Do subscribe to this channel to download my 30 years of practical experience of what works and what does not work in quality engineering to help you achieving consistently good quality products. In order to understand the measurement process, let's look at the manufacturing process at a higher level. This is an example of a manufacturing process to produce toothbrush. So we will have the process input of man, the operator that do the job, the machine or the molding machines that converts the raw materials into the finished goods, the methods on how it is done, the raw materials which consist of the plastic pellets, and the measurement process, which is our focus, and also the environment. And here, the process itself will convert the raw material to the finished good of a toothbrush handle. Let's look at what is variation. Let's say one of the key parameters that we would like to monitor is the handle, the toothbrush handle width. So what we do is that we sample 50 toothbrush from different time during the manufacturing process and measure the width using a vernier caliper. Then the data is collected against time and also the width. And then those parameters, those data is being plotted into a chart where the y-axis is the toothbrush width and the x-axis is the time. And we can see that as time goes by, the process is not very stable. It's like up and down. And when we compare it into a distribution chart such as this, where these two lines represents the upper and lower specs limit which the customers want, you can see that some of this measurement is already over the specs. And variations is actually represented by a component called standard deviation, or here to make it simple, a sigma. So a smaller sigma is always wanted, means that the process is stable and you want the measurement to be as close as possible to the desired target. Therefore, smaller sigma, the better the process. And this is what we call process variation. After we know that the manufacturing as a process, where it should consist of process input, the work or transformation process, and the output,
we should be able to understand that measurement as a process where it also consists of process inputs, the process itself or the work activities or the transformation process, and the output, which is the measurement data. The process inputs of a measurement process consist of an operator that conducts the measurements, the measurement gauge or the judgment, the measurement procedure itself, the parts or the samples for measures, and also the environment that it is measured, such as the lighting condition could be one of them, and the instruments that is used for measuring itself or the measurement process itself, which consists of could be a measurement gauge or a judgment or the eye of the operator or even maybe magnifying glass, and also the measurement data itself, the data that's collected from the process itself. So this is the overview of measurement as a process. Let's go through what are measurement gauge in this slide. It is actually any device that is used to obtain measurements and frequently referred to devices that is used in the manufacturing area or the shop floor, which could include go-no-go gauge like a feeler gauge, the automatic optical inspections, or maybe the temperature, the gauge, and the vernier caliper, and even the eye of the operator is also a type of measurement gauge where it is used to judge whether the parts is it comply or non-comply to a certain specs or certain criteria. We count, we inspect, judge, and evaluate items, and all of these activities are measurements with their own systems, and observe process variations of what you see, the whole process of collecting the data. And when we plot a chart, is actually called and observe process variations, which it could include both the real process variation itself comes from the process inputs of maybe man, machines, methods, materials, and even environment, and also the measurement error itself from the measure process. So it is very important to quantify the accuracy and the precision of the measurement system. How do we calculate the measurement error in our process? The purpose of measurement system studies is actually to isolate the measurement system error, or known as measurement variation, from the whole total variations which we observe from the measurement or the data that we collected. There is a way to calculate the variation that is associated to the measurement error, and from the calculation, we will need to know whether action can be taken to reduce the measurement error if it is not fulfilling the acceptance criteria before we continue the analysis of the data, as we do not want this component to be part of this or have too much influences on the measurement. That means it should be as small as possible for the measurement variation so that we can see the actual variation clearly. Just imagine that if you have a lot of measurement error in your variations, means that you are seeing errors in the actual errors in the measurement error in the measurement variations rather than the actual process variations. In measurement system analysis, it will help us to answer that do we trust our data because we are able to isolate the measurement variations from the total variation that we observe as stated in the last slides. As you know, accurate data is important to make good decisions. And if the variation of the measurement system is too big, we are supposed to improve it to a smaller variations or in the acceptable range. From here, we can assure our data then will be trustworthy enough to be used to make a decision. I hope you have built a good foundation in understanding MSA, which will help you to decode those complicated GR&R calculation and also able to handle any MSA related interview questions through this video. I will make another video related to GR&R in the future. Do give me a thumbs up on this video. Please do not forget to subscribe and share this channel, which is created to help you to understand quality engineering in achieving consistent good quality products. Thank you for watching.